Hello, everyone. So, we are now about to begin chapter 4, and this is what will be this is where we'll be focusing on quadratic functions. So, as always, I will be sharing my screen, and here we go. So, this is page 270, 4.1 properties of a quadratic function. So, we would be we would begin by looking at these these graphs. So these two graphs talk about a square. So this picture here, all right, is not really a graph. It is just saying that okay, so this little tiny square, okay, so would have one a measurement of one for each side. So if you're looking at this, the the smallest square has a perimeter of 4 and has an area of 1. What about this one here, the next bigger square? Well, each side would measure 2, so the perimeter is 8, and then the area is 4. This one would have side measurements of 3, the perimeter is 12, and the area is 9, and so on and so forth. All right. So this is the graph of the area of a square. All right, compared to its side length. Well, this is the graph of the perimeter of a square compared to its side length. Now, how are these two graphs the same? How are they different? Well, as you can see, both graphs are functions that relate a measure of a square to its side length. All right. Now, for this one, what do you notice about the graph? The graph of the area of a square is a curve. The graph of the area of a square is a curve. Well, the graph of the perimeter of a square is a straight line. With the graph of the perimeter of a square is a straight perimeter, straight line. Area is a curve. All right. Okay. What else can we say? No, wait a minute. Okay, I just need to erase something here. This one here. Okay. So, in what ways are they the same? Um, well, both of them, if you'll notice, are in quadrant one because the values that you can have can only be positive values because we are talking about measurements. All right. Okay. Let's go to the constructor understanding. So use graphing technology. I wrote here, use Desmos, GeoGebra, or graphing calculator to do this. Now, once you have done that, I would like you to sketch the graph by hand, all right, on all of these here, 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 on all of those grids so that you have an idea of how it looks like. Okay, so at least you have graphing technology to help you out. All you have to do is sort of copy that graph that you see using technology onto these um, grids. All right. Now there's also a question mark and it says, how do the graphs relate to the equations? All right. So at this time, I will be pausing for a while. I want you to stop this video, pause it for a while, and then graph it by using technology and then graph it by hand. All right. So please pause it now and get to work. Now, I will continue and Hopefully you were able to graph it using technology and you would have done it by hand also. This is how it looks like. Okay. So this is y equals x squared. This is y equals x squared plus 2x plus 1. This one is y equals negative x squared. Well, this one is negative y equals negative x squared plus 2x. So the question was, how do the graphs relate to the equations? All right. What do you notice? Okay, so these two, all right, these two graphs open up. All right, as you can see, the curves go up, while these two open down, going this way, right? Is there anything that you see in the equations that probably made this happen? Well, it is all about the values in front of the x squared, all right? The graphs that have positive coefficients for x squared, that have positive coefficients for x squared, open up, open up, okay? While those that have negative, those that have negative coefficients open down. Coefficients for x squared open down. So that is what this activity is all about, guys. So as you can see, all right, these two, y equals x squared and y equals x squared plus 2x plus 1, what do you notice about the number in front of the x squared? Well, it's positive 1, all right? When the number in front of the x squared is positive, the graph will open up, all right, like this. That's why I wrote this, okay? Positive coefficients for x squared, open up. Well, the next two, negative x squared plus 2x, the number in front of the x squared is negative, it will open down, okay? Negative coefficients for x squared, open down, okay? You got it? So let's look at characteristics for this. So what we have graphed are quadratic functions, okay? A quadratic function is any function that can be written in this form: y equals a squared, ax squared plus bx plus c, such that a, b, and c are real numbers and your a is not equal to 0. A cannot be equal to 0 because if it is, then ax squared becomes 0 and this function, all right, will have this part gone and it will become linear, okay? This is called the general form of the equation of a quadratic function. Now we are going to talk about characteristics of a quadratic function, especially with regards to its graph. So here we go. For some of you, it might be a lot of new terminologies. So it's like vocabulary overload. So just take it easy. After some time, you will be able to understand and memorize all of these. So whenever you're graphing a quadratic function, okay, every quadratic function, when graphed, will always be a curve. It is called a parabola. There are only two things that could happen, okay? Either the parabola opens up or the parabola opens down, all right? It's like a U. Okay? So once again, the only two things that could happen would be a parabola opening up or parabola opening down. When the parabola is opening up, just like what we have seen in the um, constructor understanding, okay? So when the parabola is opening up, um, you have a positive coefficient for x squared. When the parabola is opening down, you have a negative coefficient for x squared. Now, let's look at the highest point or the lowest point. The vertex is the name of the highest point or lowest point. If it is opening up, the vertex is the minimum point, all right, the lowest point. If it is opening down rather, the vertex is the highest point. So I'll say it again. If it is opening up, the vertex is the lowest point or minimum point. If it is opening down, the vertex is the maximum point, all right, or highest point right here. Okay, what else? So the axis of symmetry is defined as the one that the line that intersects the parabola at the vertex. It is sort of drawn vertically such that it cuts the parabola into two equal parts. That's why it says the parabola is symmetrical about this line. So in this case, right here, if this is your axis of symmetry, the left side of the parabola, which is this one, is the same as the right side. It's like a reflection, okay? So really, the axis of symmetry cuts the parabolas into two equal parts or sort of, okay? So the domain of any quadratic function is always all real numbers. Now, guys, a while ago I said there are only possible ways by which you can draw a parabola, either opening up or opening down. Both of which, all right, would tell you that it is taking on x values as it goes to the left and as it goes to the right. So let's clarify that a little bit. If it is going up, okay, you will notice that even though it is going up to the left and it's going up to the right, they're actually going um, up, but it is going to the left as it goes up. It is going to the right as it goes up. Okay, I hope that makes sense. In the same manner that if it is going down, all right. So as it is going down this way, it is taking on very small x values, so it's going to the left, and then as it goes down this way, it is going to take on right x values to the right, and then it is really just going to be all real numbers for both. All right, for both parabolas that would be opening up and opening down. All right. What is the range? The range for the parabola would be sort of different. The range for a parabola that opens up, okay, will be given by y is greater than or equal to the minimum y value. I'll say it again. If the graph opens up, the range would be y is greater than or equal to the y value of the vertex. If it is opening down, the range would be y is less than or equal to the y value of the vertex. I'll say it again. If it is opening down, the range would be y is less than or equal to the value of the y in the vertex. All right. I hope that makes sense. Okay. And that's the end of this for now. I'll do check your understanding number one in a separate video. Thanks. Bye.